In this video, we'll be looking at these Ferrero Rocher chocolates. More specifically, we'll be looking at the concept of magnification, scale, and size. For example, in this image we can see the normal size for Ferrero Rochers and then these absolutely humongous ones. So let's get off with a real life example. So maybe you don't know, but if you know, there's a character called Johnny Bravo, right? And he's pretty much obsessed with himself. So he asked his photographer to take a picture of him. Now bear in mind, he is around 2 meters tall, especially with that hair. Now then he asks the photographer to go print out this picture of him and make it 4 meters big. Okay, so this photographer goes and he prints it out. Okay, and he makes it as Johnny Bravo asked. He makes it 4 meters large. Now let me ask you, how many times was he magnified to become 4 meters large in this image? Maybe immediately you can tell me and say 2 meters. Exactly. So you managed to do that exactly out of your own head. No equation necessary, right? We know that if he's 2 meters tall, this image, this portrait that was made of him is 4 meters tall, then it means he was multiplied by 2. He was magnified twice. Okay, this image is twice his size. Okay, so you had no need for an equation and you managed to do it. But now I will show you how the equation looks like and how you actually came up with it without knowing it. So here we have it. You were thinking, okay, the size of the object, which is Johnny Bravo, is 2 meters, right? Now, we wanted to find out how many times he was multiplied. So you said the size of Johnny Bravo, so the size of the objects, multiplied by a certain number will be the size of this portrait, right? And in your head you knew, okay, if he's 2 meters tall, so let's get to it. If he is 2 meters tall, times whatever magnification we're trying to find, he must be 4 meters tall in the image. So what is the magnification? So all you have to do, right, is divide each side by 2 meters to isolate magnification. So like this, divide each side by 2 meters, then we have 4 meters over 2 meters is magnification. Now we can just do the simple math and get to the answer of magnification is 2. So he was magnified twice. So the equation I'm trying to get to is this one. It's exactly the same as this one, just rearranged, okay? Because this is the one you kind of use in your head without knowing it. If you rearrange this equation for magnification by itself, what you'll have is magnification equals size of image divided by size of object, if you divide it down here, right? And by size of image, I mean the non-real thing. So in this case, the portrait. And by size of object, I mean the real object. So in this case, Johnny Bravo. So obviously, they don't always use these nice examples, like with real people, with real objects, that makes it easy to understand. They always use quite complicated ideas, like they use cells and really tiny things to make you do this calculation. So we'll get to an example that uses cells just so you can understand, but it's pretty much this exact concept. All they do on tests is for example, in this example, I asked you to find magnification, knowing his size and the final image size. But on a test, they could actually give you the magnification and give you the size of the image and then ask you to solve for the other thing. So just bear in mind, they can always ask to solve for any of these 3 things. Okay, as long as you have 2 of the things, you can solve for the last thing. So they won't always ask you for magnification necessarily. Could be any of the other things. Now, a way that I found was really easy to remember this equation was this. So here's the equation again. You make this triangle, right? And this triangle, you put on the top SI, which stands for size of image. So this is the non-real thing. So for example, the portrait. And then in the bottom, you put magnification, so M for magnification, and then size of object, which is the real thing. Now, if you get asked on a test to calculate magnification, and you forgot the equation, but you remember this triangle, then you can so easily figure out the equation. For example, let's say you need to calculate size of image. So what you do is you cover size of image And as soon as you cover size of image, this is your equation. Mass times size of object. So whatever you cover will reveal the equation that you need to use. Okay, so covering size of image will mean magnification times size of object. Okay, that's your equation. Now, what if your teacher says, calculate magnification. So then you cover magnification. Now you have your equation. Size of image divided by size of object. Now last one. What if he asks you to calculate size of object? What do? You cover size of object, and now you have your equation. Size of image divided by magnification. So I find this equation, this diagram really useful to remember because it makes it really quick. You cover what you want to find, and it reveals the equation. So it's a pretty nice idea if you can't get this equation in your head, or if you struggle with rearranging the equation quickly. Okay, let's get to a question that's more realistic to science. So it's pretty much the same concept. So I want you to try it by yourself first. So the question is, the size of a cell is 0.25 millimeters. On your test, the image of the cell is 10 centimeters in size. What is the magnification? So we know already we need to calculate the magnification. So basically, same thing. Somebody took a picture of the cell. The cell's real size is 25 millimeters. We're going to pretend it's 25 millimeters. Because I already did the math and stuff, so I don't want to... In reality, that's already pretty big, but we're going to pretend it's 25, just because I already planned it this way. So it's 25, so it's a really freaking big cell. And on the test, so when they printed it out, the image was 10 centimeters big. And they're asking you how many times was this cell multiplied in size to become 10 centimeters. So what we do is, again, we look at the equation. Here's the equation. And if you don't remember the equation, again, cover what you need to find. We need to find magnification. So we're going to cover magnification. And now we know it's size of image over size of object. Now, do we know the size of the image? Yes, we do. It's 10 centimeters. So we're going to put it in. It's 10 centimeters over the size of the object, which is 25 millimeters. Okay? So what you need to bear in mind here now is that if you just calculate this, the magnification will be wrong because the units are not matching. So you need to make sure you either convert centimeters to millimeters or millimeters to centimeters. Either way is fine. You just need to make sure the units are equivalent. So I put a sun here because I'm going to talk about the concept of conversion and how to convert in the next part. So just for now, just follow me. So how do we convert 10 centimeters into millimeters? We know that to convert centimeters into millimeters, we need to multiply by 10. So we multiply 10 by 10, and that brings us to 100 millimeters. 100 millimeters is the same thing as 10 centimeters. But now the units are equivalent, millimeter and millimeter, which means we can do the math and the answer will be correct. So after calculating it, we can find that the magnification is 4. So the size of the cell on your test was 4 times bigger than the actual size of the cell. And just bear in mind, no cell is actually 25 millimeters. That's really big. So this number is not super realistic. But just to get the concept. Okay, so now last part. I want to talk about this, the sun, the bright sun. How to convert. So to convert, I use this little diagram. To convert meter into centimeters, you got to times by 100. 100 centimeters is 1 meter. Now to convert centimeters into millimeter, you got to times by 10. So 1000 millimeters is 100 centimeter, and so on. You can see this. So just if you know how this diagram works, then that's all you need to know. This is all you need to convert. And again, if you want to convert back, so you want to convert nanometers into micrometers, you just need to divide by 1000 instead of timesing by 1000. Now, so to put this in perspective of how small a nanometer is, if the tallest building in the world was 1 meter tall, then 1 nanometer would be the size of a single hair strand next to it. So that's how crazy small a nanometer is.